Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When analyzing conformational stability, we must consider both steric interactions and intramolecular interactions such as hydrogen bonding. The compound is 3-hydroxypropanol, OCH2CH2ChO. We are asked to consider rotation about the C2-C3 bond. Moving on to the next step. Identify the groups on C2 and C3. C3 bears OH, C2 bears ChO via C1, H. Moving on to the next step. Consider possible conformers about C2, C3. The Newman projection looking down C2, C3 would have front carbon, C2 ChO group and 2 Hs. Back carbon, C3 OH group and 2 Hs. And for the final step, evaluate stability considerations. In the fully staggered conformer, the OH and ChO groups are 180 degrees apart, maximum separation but no opportunity for intramolecular hydrogen bonding. In the gauche conformer, the OH and ChO groups are approximately 60 degrees apart. This proximity allows the hydroxyl group, OH, to form an intramolecular hydrogen bond with the carbonyl oxygen, C is equal to O, of the aldehyde group. This intramolecular H bond stabilizes the gauche conformer significantly. Why other options fail? A. Staggered although it minimizes steric strain, it does not permit intramolecular hydrogen bonding between OH and C is equal to O, so it is less stable than gauche for this specific molecule. C. Fully eclipsed, maximum torsional and steric strain, least stable. D. Partially eclipsed, still has torsional strain, not the most stable. Conclusion. The gauche conformer is most stable because it allows intramolecular hydrogen bonding between the OH group on C3 and the carbonyl, C is equal to O, on C1, which provides extra stabilization that outweighs the slightly increased steric interaction compared to the anti-conformer. Therefore, the correct answer is B. Therefore, the correct answer is option B.